why are these Amazon, Microsoft, Google, these companies called hyperscalers?
Yeah, hyperscalers because they've got massive infrastructure across the world. The two lifelines of a data center are fiber and power.
What's your advice to the current generation of founders?
First of all, it's dream big, right? Especially with AI, you've got this opportunity to create something from for the world. You just don't have to look at India alone.
Sharad, welcome to the Founder Thesis podcast. You are a pioneer, both as a tech founder and in the space of cloud computing. Um, I want to kind of take you back to 1998 when you started your first venture. What was it like? What had you gone through? How old were you when you thought that you should start a venture? And 1998 means pre VC era, pre tech startup era, and you were doing a tech startup at that time. So I just want to understand what that era was like and what you were like.
First of all, Akshay, pleasure to be on your show. Um, So I did my undergrad from IIT Bombay and then my master's from Columbia University, New York. At Columbia, I was fortunate to work on the first large backbone of the internet called the NSFNET. So in the early days of the internet era, I was fortunate to work for this company called ANS, which ran the largest internet backbone, which was funded by the National Science Foundation, hence called the NSFNet. The main purpose of that backbone was to connect research and education institutions over a high speed network, right? And of course, then we connected that to the commercial internet exchange, and so then it connected to the overall internet as well. Um, I moved back to India in '95 when the government announced that they would offer commercial internet services. They would allow, internet to be commercialized in India. It was still a monopoly of Videsh Sanchar Nigam Limited. So from '95 to '98, it was a monopoly of BSNL. I was again lucky to be appointed as a consultant to BSNL. I actually went there because there were some issues they were facing, and I told them that I could fix some of those because I had prior background in the US. And they asked me to, on the fly, fix. They said a lot of people come to us saying that we can fix things. Why don't you show us what you can do? And I was able to, fix some of that stuff. So they gave me a consulting
Was it
contract.
hardware stuff or software stuff?
Well, it was basically configuring of the routers. So it was,
Okay.
they used to use Cisco routers, and they had some they were not configured properly, and so I was able to fix those, and so they gave me a consulting contract to help fix the and help grow the internet backbone in the country. So that actually helped me. So I started a consulting practice where I consulted not only to BSNL but to a few large corporates like Reliance Industries and others, where basically my aim was to help scale large networks, right? So it could be satellite-based networks, it could be fiber-based networks, etc. And so while so that from '95 to '98, I was pretty much doing that, and so I was doing consulting for various companies and for Videsh Sanchar Nigam Limited. In '98, the government decided to allow private players to enter the internet area, right? So the ISP license was they started
Internet service
issuing.
provider.
Yeah, internet service provider license was issued in the year 1998, and that's when I said that it's a good idea for us to set up a company because we'll have again initially we didn't have capital, so we said, oh, we'll set up a company and we'll now the consulting practice, instead of me doing it alone for one or two customers, now there is a whole bunch of customers who are because many people, there was Satyam Infoway, there was Hathway Cable, there were many people asking for internet licenses, Tata Internet, etc. So so a group of me and two or three others that I found in the journey from '95 to '98 decided to set this up. And while doing this consulting, so we had not raised any money. While doing this consulting for private players, we noticed that most of them were doing only dial-up access or broadband access and catering to end users, but nobody was really focusing on how internet could be used for mission critical business. And that's when I was also lucky that in one of the Thai conferences in Delhi, I met the founders of Exodus. And since I was a consultant to VSNL at that time, they were looking to see what they could do with India between Exodus US and India. Exodus, by the way, was the basically the first company that started internet data centers in the US, right? And became at one point reached $25 billion in market cap. So BV Jagdish, I met in a Thai conference, and I told him my plans. That look, I've seen all these service providers are looking at focusing on retail users and broadband access, but nobody's looking at how internet can be leveraged for internet data for mission critical use. And is there a possibility that I would like to figure out if I could raise money to actually set up internet data centers, much like what you have done in the US. And given my background of NSFNET, etc., he was, he took a liking to what I had to say and invited me to the US. So he showed me a few Exodus data centers and also, agreed to angel invest in early 2000, late 99, early 2000. And once he decided to invest, by then, Exodus, as I told you, was at its peak, and everybody knew these founders, BV Jagdish and KB Chandrasekhar. So, the moment other investors heard that Jagdish is investing in us as an angel, that we had no difficulty in raising venture capital. And we raised $4 million and set up our first data center in Mumbai. It was a very small, 5,000 expandable to 15,000 square foot data center. And but what happened was within a year of setting it up, the entire industry collapsed because the dot com bubble went bust, and many clients in these third party data centers in the US were dot com companies that basically ran out of business, ran out of money, and so there were a lot of bad debts, etc. And many companies had leveraged a lot of money to build, because these data centers are very capital intensive, and so they'd taken a lot of debt that they could not service. So many companies, including Exodus, actually collapsed. And yeah, but it was very exciting times. We fundamentally believed in the model, which is that you are actually you know providing a solution. You're making enterprises focus on their core business, and you're actually taking over the infrastructure headache from them, and you're sharing the costs across multiple enterprises. So it was a win-win relationship, and so we just kept at it, and things
Okay,
turned over a
uh,
period.
I want to pause this journey a bit here and understand a few of the terms that you used. You spoke of the internet backbone. What is the backbone of the internet? How does the internet run fundamentally? Is it fiber
So
optic cables and servers, or what is it?
no. So what I meant, the main network that connects. So in the early '90s, the main there's basically you can connect various locations using either fiber or satellite or whatever. But obviously now it's mostly fiber. And at that time we were, I'm talking the early '90s. At that time, the speeds that we were running were about 45 megabits, which was called a T3 network or DS3 network, right? And the backbone prior to ANS getting the contract to run the large NSFNET backbone was internet backbone was running at a T1 speed, which was 1.5 megabits per second. Today we have several
Backbone
gigabits.
backbone refers to the pipe
Yeah.
between.
So basically, the backbone is internet is a network of networks. So it's basically all multiple networks that are interconnected using, and they're all using the IP protocol, right? Internet protocol. So they are able to exchange data, and basically there's an addressing format called the IP address. And based on the source, it's like when you write a letter and you have a postal system. Think of the analogy to the postal system. You write an address, you have certain uniqueness in the address, like the pin code or whatever. Here you have IP addresses that are unique, and based on the address, it can go through multiple post offices across the world. So postal system is a network of networks. Similarly, internet is a network of networks. The post office here is equivalent to a router on the internet, which looks at the destination IP addresses and figures out the next router to send the packet to until it reaches the destination. So backbone is referring to the core network that connects all these routers together. And the backbone that we built in 98, early 90s, sorry, was the backbone. We upgraded the backbone that connected all the research universities. So it was the research and education network that we built, and obviously that was connected to the other commercial part of the internet through internet exchanges. Yeah.
Okay, got it. And the internet still works like that today also. Like there are
Yes, it's just the
routers which,
speeds. Yeah, speeds
yeah.
have gone up several fold. We were talking of 45 megabits. Now there are several terabits per second that is running on. Gigabits per second and terabits per second. Backbones have actually gone to several terabits per second. So think of the when you're scaling a large network, you have a core network, and then you have local networks in a particular region, and then you can have a local area network in your office, right? So that connects to a regional network, which connects to the main backbone network. And there are multiple backbones that are running that are all interconnected. They could be interconnected through private peering, where they connect between each other, or they could be connected through an internet exchange, where you again could use either private peering or public peering.
What's an internet exchange?
Internet exchange is a neutral place where multiple service providers bring their equipment routers together. So they co-locate the routers typically, right? Bringing the routers together or the switches together, and it's a means to exchange traffic based on a particular policy that the exchange follows. Typically, the most common policies that people follow are what are known as private peering, where you have bilateral agreements between providers that based, that this is how we'll exchange traffic, and but you also have public exchanges that are available where anybody can exchange traffic with anyone. So depending on the policy, you exchange traffic accordingly.
Okay. What is the difference between a router and a switch?
Again, when I met a switch, if you look at the layers of TCP/IP, right? Uh, when you loosely use the word switch, you typically use something like an Ethernet switch. That is something that operates at layer two. A router operates at layer three. So router actually recognizes IP addresses and routes based on IP addresses. But now you can use a layer three switch is like a router. So you can have actually switches can be either at layer two or at layer three.
What
Again,
is a what is layer one, layer two, layer three here?
so there's this seven layer of TCP/IP where you have the physical layers, layer one, you have the MAC layer, which is layer two, you have the IP layer, which is layer three, you have the transport layer, which is layer four, etc., and then the application layers on top, right? So when you're looking at Ethernet frames, when you're looking at the Ethernet layer, which is your typical local area network that you use in your offices, that is typically the device that interconnects your, for example, your personal computers, etc., is a Ethernet switch, which is operating at layer two. Now you can also have an Ethernet switch that operates at layer three, so it can actually route between different Ethernets, which operate at layer two, right? So
Okay, okay.
that's a separate session where we can go
Hmm.
into
Yeah, yeah, yeah,
details.
yeah. Who are the? So you said that at an internet exchange, internet companies will come and exchange data with each other.
Yeah,
The
they can
internet
actually
companies would
put only
be
the they could actually put only co-locate only the Ethernet switches, or they could even co-locate the layer three devices like routers and switches
okay,
that they could do, and then exchange traffic. Yeah.
okay. And these companies are like Airtel, Geo. These are the
Yeah,
internet
so in
companies.
India, for example, in an internet exchange, like we have a exchange in India called NIXI, National Internet Exchange of India, which is again a neutral exchange where you have people, service providers like Airtel, Tata, NTT, others that all interconnecting and exchange traffic based on a particular policy.
Okay. What would be the journey for when I open my uh, phone and open the Netflix app and I start streaming a movie?
Yeah, so what you're doing is when you open an app, so there is a there's on the internet or on the cloud, if that people commonly call, there will be a bunch of servers running somewhere in a data center. Okay, and when your app connects to the server, there is a request that is sent. A packet is sent to the server saying that I would like to view this content. The server gets the request, maybe do some authentication to see if you're a valid user, and once does the authentication, sends the streams the data to your device. And the but all the data is routed through the internet protocol using the way that I mentioned. That's the way it would route. So the Netflix servers could be sitting in maybe in a different country, or hopefully in your local country. Now, typically, Netflix has distributed their setup across the world using a public hyperscaler provider like an Amazon and others. And so you typically, and since Amazon is present in India and the US and in many countries, at least in those countries, you'll have serving happening locally. You also have this concept of caching, where you can cache the content. Caches are these repositories where with fast memory you have, you capture the content locally, and you can then, based on the request, you can stream it from the nearest cache, if you will, right? When you click on your app, Netflix app on your iPhone, you basically that app will connect to the server in the cloud, Netflix server in the cloud. It'll do the authentication and then request you to stream data.
Okay. So you started a data center. What is the difference between a data center and a cloud?
Great question. So again, these terms are, so a lot of loose definitions of these terms, and there's no one correct definition. But typically a data center is a place where you house server infrastructure. So you have lesser people in that facility. It could be a lights out facility, and you have a lot of servers typically housed in these data centers. A data center's job is to make sure that the two lifelines of a data center are fiber and power. So you need to make sure that power is available round the clock. You need to ensure that connectivity through multiple service providers is available round the clock. And of course, you have other things like you have to have the proper cooling. So because the servers generate a lot of heat, you need to make sure the servers don't overheat. So you have to have temperature control and humidity control. And of course, you have to have security so that nobody can just randomly come into a data center. So there are many aspects of it. That's what is called a data center. Cloud is, typically cloud, the cloud. So if I talk about cloud, there are multiple definitions again of cloud. But when you say that, okay, this is running in the cloud, it's running somewhere on the internet. You don't know where it is running, so that's why you call it cloud. That's one way of looking at it. More strict definition of cloud has multiple layers. Again, you have something called infrastructure as a service. So if I house some servers inside a data center, which is connected to the internet, and I provide that infrastructure as a service. So you don't actually buy the infrastructure, you rent it as a service. Then that's called infrastructure as a service, or IaaS. The next layer is if I run some software on top and provide you a platform which abstracts the infrastructure underneath. So a developer just needs to develop using certain APIs, but doesn't need to really worry about the underlying infrastructure. That's called platform as a service. And then the third is software as a service, where if I offer you the actual software as a service, like Netflix in this case, or your Gmail in another case. Gmail is a classic example of software as a service. Then that is called software as a service. So these are all different layers of cloud. Some people refer to cloud on infrastructure as a service layer. Some people refer to cloud as platform as a service, and some people refer to it as software as a service. Some people, so a data center typically refers to the physical location where these servers are housed. So cloud is typically housed in a data center. But again, a lot of these terms are used interchangeably. And an internet data center, you could have a captive data center which is not connected to the internet. But when I'm referring to as data centers, internet data center, where you have a lot of connectivity to the internet, so that any application that's housed in a data center, whether it's Netflix or Gmail, can be accessed to the globe.
Okay. Okay. So a data center also buys the servers, or is a data center like a real estate business where you have
Oh,
a
okay.
building and you
Great,
have
great
cooling
question.
and electricity
Great,
and
great
connectivity?
question. You have multiple models, right? So you can there is something as a co-location provider. So data center can be a pure co-location provider where they provide the mechanical and electrical infrastructure. They provide the connectivity infrastructure. They provide, and the connectivity, again, they don't need to own the fiber. They can just provide a meet me room where they bring in all the telcos, and so they can provide a cross connect service to the person who puts their servers in, and nothing else. So that could be pure co-location provider. A data center may also provide some services, as by putting up a cloud in their own cloud inside the data center, like we did in NetMagic. We in addition to providing co-location services to others, we also put our own servers. So a lot of customers not didn't want to buy the hardware and said, okay, can you actually provide me the infrastructure as a service, or platform as a service? In which case, we provided not only the infrastructure but also the platform on top. But again, majority of the data centers across the world are co-location providers. The really large players, they provide the facility where there is very high uptime, there is round the clock power, round the clock connectivity, and also very secure facility with proper cooling and humidity control, to clients. And some of the anchor clients in the world are your hyperscalers like Amazon, Google, and Microsoft. Right? And then, of course, you have a lot of enterprise clients like banks, financial institutions, manufacturing companies, retail companies, etc.
Okay, okay, got it. Infrastructure as a service is not this real estate business. Infrastructure as a service includes the servers also.
Yeah, yeah. Infrastructure is the underlying real estate with the mechanical and electrical equipment is the data center piece. Infrastructure as a service actually means I'm providing typically the servers for my cloud offering. Yeah, servers, network storage, etc. Yeah.
But you're not responsible for installing an operating system on the server and
No, no,
upgrading the software.
we are. So
Okay.
if I'm just doing a co-location, then I'm not responsible for anything else. Then the client is bringing his own servers; he's responsible for everything else. I could be providing him the servers and be responsible for the all these things. Again, there could be in two flavors. I could do it as a public cloud offering, like much like what Amazon, Google, and Microsoft do, or I could do it as like a private cloud offering where I have a dedicated infrastructure that's not multi-tenanted. It's dedicated to one particular client, and I may be responsible for the setting up the operating system, setting up the web servers, setting up the database servers, etc. Again, it depends. If the client is more comfortable setting it on his own, then the client does not outsource these. But typical cloud provider will do all of this.
I'm not very clear on infrastructure as a service versus platform as a service, because in infrastructure as a service also you are giving servers with the software installed and all of
No, no,
that. And
platform is another layer of software on top where you abstract the infrastructure. So the client does not, then you just connect, a client connects through APIs. I could provide a service like a, Kubernetes cluster, and a client just needs to connect to that, through an API. Doesn't need to really there's one additional layer of software that's provided to abstract the infrastructure below. So client doesn't need to know. So typically developers like to use platform as a service. Typical examples are these are examples of what Amazon, Google, and Microsoft provide as global hyperscalers, and a lot of people just use their platform as a service to without worrying about the underlying infrastructure. The platform takes care of managing the infrastructure below.
Hmm. So in infra as a service, your atomic unit would be number of servers, whereas in platform as a service, it would maybe be something like GB or something like that, where you don't care about how many servers are being used, but you care about how many GB or something to that effect.
Yeah, typically an infrastructure service will be virtual machines and containers, because I will take a physical server and virtualize it. And typically in platform as a service, it could be different ways that people can build it in the AI compute. It could be just number of so there are different ways I can build a infra. If it's a serverless offering, then it will be number of tokens. If it is a if I'm using a platform, it could be number of API calls. Although now nobody API calls become very difficult to build. It could be just the cost of using the platform. Yeah.
Okay, 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 got it. Typically, like not AI cloud, but like the regular cloud, how is that built? Like an AWS?
So you have a whole set of servers. You have a virtualization layer on top. You could use something like a VMware, or you could use a open source virtualization layer like KVM, and so that you can abstract the physical infrastructure. You can break it up into a lot of let's say I've got hundreds of servers. I've got storage. I've got network. I can virtualize the whole thing so that I can create multiple virtual machines. Because what people realize is, in a single server, once you have multiple servers, a lot of the compute was lying unutilized, right? And so that's why virtualization was born, and the company that revolutionized virtualization was VMware. And then, of course, there were open source versions of virtualization software, or hypervisors that they were called. So once you have, you can abstract you can create virtual infrastructure from physical infrastructure to improve the utilization of that infrastructure, right? So if I on one server I can have 10 virtual servers. On a group of servers I can have hundreds of virtual infrastructure, and that way. And of course, there are a lot of other qualities of hypervisor like VMware and all. It gives you, if a physical server goes down, you can automatically migrate all your virtual infrastructure on a different physical server, etc. And so that's the real benefit of virtualization. So you have first the server layer, you have the hypervisor layer, you have the storage where where you store all your data. You have the network that connects multiple things together, both east-west network to connect multiple servers within the data center, and then north-south to connect it to the internet. And then you have security infrastructure. You have like firewalls. You have your load balancing infrastructure. When you have a lot of traffic coming to a particular application, let's say Netflix, you want to load balance it across multiple servers. So you have load balancers, etc. So all that's a physical infrastructure that you deploy to set up a cloud offering or an infrastructure as a service.
Okay, okay. And typically, a developer using AWS will be paying per VM, per virtual machine.
Yeah, again, many developers don't like to. So many developers use their platforms. Like in the AI space, their platforms are called SageMaker and Bedrock. So they use the platform itself, so they don't then need to worry about underlying infrastructure. They may still
So
get
then it's
exposed
just
to it.
per token or
Yeah,
something like that.
no, not per token. Then no, that's when you do endpoint as a service or inference as a service. Here, there'll be a fee, there'll be a platform fee that they'll pay, right? Which will there'll be when you're doing infrastructure as a service, you're paying a fee for the VM or for the container. Here, you'll be paying in addition to a platform fee as well.
Okay, okay, okay. Got it. Okay. Why are these Amazon, Microsoft, Google, these companies called hyperscalers? I notice you use hyper in that
Yeah,
hypervise
hyperscalers,
also.
because they've got massive infrastructure across the world.
Okay.
They've set up these, massive server farms that they've either built themselves or leased from third-party data center providers like NetMagic NTT, and then provide their services on that. And they've got the scale is huge, which is why they're called hyperscalers.
Okay. Okay. Got it. Got it. Okay. So when you started NetMagic, at that time, who were your competitors? I don't think AWS even
No, no,
existed at
no.
that
So
stage.
when I started NetMagic in '98, we were the first data center provider. Within a
Hmm.
month of our starting, I think Satyam Infoway, which is now SIFI, started the data center, and then there were others like Tata, Reliance. They all started the data centers as well. Yeah.
Okay. And you were providing virtual machines to your clients or co-location, like one of these
No,
two.
initially it was a combination of co-location and what we call as managed services. So we would allow the customers to bring in their servers. We would also manage, install the operating system, database, web servers, manage it for them. So it was a combination of co-location and managed services. Later on in 2009, we set up our first cloud offering. So the cloud business started in the US with through AWS in 2003, if I'm not mistaken, or 2003-4 timeframe. We were the first ones to start cloud in India, indigenous cloud in India called Simply Cloud, which was in the year 2009, 2008. 9.
So you raised 4 million through an angel round to set up the data center business. By the time you were setting up the cloud business, had you raised more funds, or just through the cash flows of the business you were able to continue to expand? And
It's a great question. So we raised the first 4 million. It was a combination of venture capital and angel, right? Around, and then Before we could raise the next round, as I said, there was a dot com bubble that burst, and so we then used the cash flows of the business. Our business became cash flow positive within 13 months, and we obviously we did not waste money doing massive ads and all, which was the case in those days. People spend a lot of marketing, and you could see the dot com ads and billboards and stuff. We did not waste any money,
But you were
and
in the B2B
yeah,
space,
we were in the
targeting
B2B
only,
space. Yeah,
and
no,
not only
I've
that, but
always
you
been
were
in the
only
B2B space. I don't
right, right,
understand the
and
B2C
only
space.
enterprise clients, right? You didn't even need to go to mid-level companies.
Yeah, yeah. So we no our initial customers. A lot of our venture capitalists are, like for example, eVentures was our first investor, and they had got some dot com investments who also ended up hosting with us. So we also had that those bad debts, but we focused more on enterprise, and we gradually built the business. When we knew that we couldn't expand our data center footprint till we got more capital, we started offering more value-added services like. The managed services I was saying, providing operating system management, database management, web server management, security management, network services, etc., selling more internet bandwidth, etc. So we did all of that, and in 2008 we actually raised our second round of funding through Fidelity and Nexus. Nexus bought over the stake from eVentures and then put in some more money. We raised $15 million in 2008, and we set up two more data centers with the money that we raised. Of course, cash flows also are very positive. We were hugely profitable then when Nexus and Fidelity decided to invest in us. And then we raised our third round in 2010 through some strategic investors like Cisco and Nokia. So in addition to Fidelity and Nexus, we had Cisco and Nokia. And then
How much
finally
was
in
the third?
2012,
How much was the
entity,
third?
pardon? The third
How
round
much
was
was it?
$12 million. $12
Okay.
million.
Hmm.
And then in 2012, entity acquired us, took majority stake. I still kept my shares, but entity acquired all my other investors. They also gave an exit to not only my investors, but also to my employees. And then in 2017, they acquired my balance stake because they were in the process. At that time, they were thinking of how they can merge their multiple businesses together. So that was the journey.
Okay. Okay. Um, why doesn't India have any Indian-born hyperscalers? Like the way, like all the hyperscalers are all American or Chinese companies. Also, I guess probably would come in that, but there is no Indian hyperscaler.
Yeah, hopefully we'll change that in the AI space.
Okay.
So in the second venture, Neysa, which I started in July 23. So I continued in NTT from until 23 July, June end, June 30th, 2023. And now I'm on the board of the India company, but I'm not an employee. And I set up Neysa in 23. At Neysa, we're looking at building an AI cloud platform, which we want to scale across the world. So yes, you're right. So far, we haven't had any major
But why
hyperscale.
is it because of demand that the Indian demand was very small, so therefore
No, but
you couldn't expect?
there's no reason why an Indian company cannot set up. If an US company can set up a data center, the infrastructure in other markets, including India, Europe, Asia, everywhere in the world, why there's no reason why an Indian company can't do that. But a lot of it is to do with the fact that the entire ecosystem. Even if you look at it, Amazon started, Microsoft then caught up, and then Google was a late entrant, but even Google has managed to catch up. They've spent billions of dollars, so it's in doing this. Of course, it's hugely profitable for them also, but I'm saying they've spent a lot of money doing this. So it requires, and they've got few thousand engineers working on automation, etc. So there's no reason why an Indian company cannot do it, but and hopefully that will change in the AI space. But after a point when when their footprint became, the barrier to entry kept on increasing as they started proliferating. Right, even for Google, it took a while before they could become a serious contender in the space. And the Chinese hyperscalers have done very well in China. I'm not sure how much success they've had outside China, but they've done. Obviously China is a huge market for them. Um, An Indian hyperscaler just in India, yes, you may be right. For example, on the AI space, India's footprint of AI footprint is much smaller than the US and China currently. Hopefully, that will change over a period of time. But there's no reason why you can't replicate what you do in India across the world. It's difficult to break into. It requires a lot of capital, and also it's difficult to break into an already established ecosystem, which is why there's inertia. And people have rather said, okay, rather than me trying to fix something, there are already three global players or multiple global players doing that. Why don't I look at how I can leverage those players and build something else that is global in nature, right? So
Okay. Why did you decide to sell to NTT?
that's a great question. So I'll tell you what started happening in 2011-12. There were a series of M&A, transactions that happened in our space. So there was an acquisition that happened in Brazil. There was a company called 21 Vianet that went public in China. And so naturally, as these people were looking, as these global players were looking to expand in other markets, India, Brazil, India, and China were three of the hottest markets. So people started looking at India. And in India at that time, you either had the big players that were already public, like your Tata and Airtel and Reliance, or you had a small, mid-sized player like us. That was We were probably the only player of reasonable scale that was not public. So we were the only player that was of a reasonable scale that was which had multiple data center locations, had a whole suite of managed services offerings, including our cloud offering, but that was not public. By the way, we were looking to go public. Okay, so we had had board meetings to say that okay, in 2 3 years we should go public once we reach a certain revenue threshold, etc. But suddenly we started seeing inbound offers. So we had multiple companies approach us saying that would we be interested in doing something with them. And I met one company, I met two companies, and then I went to my board and said, look, I'm getting all these guys' interest, but I just don't have time to meet everybody, go through all the song and dance, and then, and also run my business. So what the investor, and at that time, as I said, we were discussing when we could take this company public. So investors said that, look, why don't we hire a banker, let them run a process so your time is saved, and if you can get a valuation that we would get if we were to go public, then then why not, right? And
Yeah,
so
it's safer than
yeah,
going
so
public.
why don't we do that? So that's what we did. We hired Credit Suisse as a banker, and then they ran a process. There had about 12 parties interested in us. Finally, after some discussion, we shortlisted it to two. There was a U.S. large private equity player and entity of Japan. And I think what we liked, why we selected entity was we found a lot of similarities in our aspirations. Like I didn't want to exit the business at that time, so I found with entity I could continue to grow the business myself. Plus, entity was giving me a platform to take some of our services global. By the way, in 22, I was running the global business of entity as well. And we just like the cultural match, right? I still remember there was the day I met entity for the first time. There was a in Bombay, in our data center, there was a series of train blasts that happened, bomb blasts that happened on local trains. And I thought they'll cancel the meeting, but they still came, right? And they were not phased with that, right? So a lot of such things, and even when I spoke to my co-founders and I spoke to the people when we interacted with entity, they all, I think there was a lot of um, comfort working with entity, which is why we selected entity over the US private equity player.
Okay, okay. You said the hyperscalers, it's hard to compete with them. There are a lot of barriers to entry. You need to spend billions of dollars. Um, is this spent on the infra? Like
No,
you
it's
need
a
to have
combination.
real
See,
estate and
infra.
hardware.
No, no, it's infra, it's people, right? They've got they've got an army of close to 10,000 plus people working on this automation that they're doing on cloud, and they've been doing it for so many years. So, how do you just overnight catch up to that? So that's number one. So they've built these barriers over a period of time. There's also infra, the kind of infra that they've scaled across the world. So you need a lot of investment. I mean, it's not that you need billion-dollar infrastructure on day one. You obviously will grow the business every year. But it is difficult. Plus, they have other, over a period of time, Amazon, Google, Microsoft have other services that they cross subsidize. Microsoft cross subsidize the licensing. Google will give you access to YouTube and search engine optimization, etc. Amazon will also give you a whole bunch of other benefits other than just the infrastructure. So it's a non-trivial. I personally felt NTT could have taken our cloud, Simply Cloud in India, and taken it to other parts of the world. Right? They decided not to, and they decided to resell. While our data center business did really well, but our cloud business was limited just to India. I personally felt NTT should have attempted to take that across the world.
Okay. Okay. The what are the automations that cloud providers provide? Couldn't you just get a white labeled software solution to uh, put it on top of your servers and be able to offer the same thing as an AWS offers? Like,
No, no. So there are, for example, the orchestration that is done where you do where you provision a virtual machine or a container and then allocate resources to that. Yes, there are providers that provide that software that you can directly deploy in your servers. But that's not all, right? There's an entire platform layer on top that these guys have built over a period of time. And not everything that has been built is available through a third party software.
so now your Simply Cloud business. How did you manage to scale it when you didn't have the kind of technical workforce to build these automations which these
So
hyperscalers
we did
offer?
so the way we did was, there's a 90-10, 80-20, or a 90-10 rule. There are If there are 100 features that the hyperscalers have, what we found is 90% of the customers only use 10% of the features, or 80% of the customers only use 20%. So we focused only on those limited set of features, and obviously there were some customers we could not target because we didn't have certain features. So we also had alliances with Amazon, Google, and Microsoft. So if we found that there was some feature that the customer wanted was not in our portfolio, we would resell that. Otherwise, we would our objective obviously was to sell our own first. So a typical customers didn't care where you hosted it as long as you did the job, right? And you gave the service level agreement. So a lot of cases we were able to fulfill customer requirements with just 10% of the features that an Amazon, Google, or a Microsoft would have. And that's how we scaled that business. We had a lot of customers, enterprises, startups using our cloud, still using our cloud till date.
Mm. So at 2012, you were roughly 150 CR kind of a revenue number. How much of that was the cloud business? How much was data center?
Data center was I would say, bulk of the revenue. I would say, if I were to split that revenue into four buckets: data center, cloud, managed services, and data center, cloud, managed services, and network, right? Roughly. Network would be 10%. Um, I think data center would be 50%. Managed services would be 25%, and the balance would be cloud.
Okay, 15 odd percent. Got it. Okay. So once the entity investment came in, then how did it evolve? You focused more on
So then
the
we
data
started
centers, or?
building multiple location data centers. We used the investment. First, we had used the Fidelity investment to build Chennai and Bangalore. Then we used entity investment to build larger data centers. Because as the footprint grows larger, some of the overhead gets split over a larger area, and so it becomes more cost effective, more energy efficient data centers, larger data centers. So when I left entity, we had 19 data centers, close to 300 megawatts of IT load in production. Clearly, India is number one. Out of 1.2 gigawatts when I left, we were close to 300 megawatts. So it's almost like 25% of India's capacity. 19 data centers. So we used the money mainly to build our data center capability. Of course, we grew the team as well. We launched a whole bunch of new services. We also offered our managed services. We offered remote managed services to other entity companies across the world. So entity had clients like Sony and others across the world that we were managing from India. So we did there was a lot of synergy. We used some of the best practices when we were building our data center in Noida. Entity gave us a best practice of how they build data centers in an earthquake prone region like Japan. So we used some of those best practices. We used dampers to mitigate the risk of an earthquake, so that the whole building can kind of shift if there's an earthquake. So they shared some best practices with us. We shared a lot of our knowledge with them, and we built a very sizable business in India. Um, where I think when I left, if I combined the business of network, cloud, data center, and managed services, it was north of close to between 400 and 450 million dollars.
Wow. Okay, that's amazing. That's a massive growth from 2012. Okay, amazing. Okay, so and Entity is largely a data center company. They didn't want to be a cloud company.
No, so NTT, if you look at NTT in Japan, started out as a telecom company. They were the equivalent of BSNL and BSNL in India. So they were the national domestic carrier as well as the national international, as well as the international carrier of Japan. And then they got into data centers, and then of course, now they're a full stack company. They've got entity data that does in software development and application development, including in AI. They've got this entity global data centers that runs the data center infrastructure. They've got one of the second or third largest submarine cable network for the network services. They're a tier one ISP. They were one of the largest ISPs in the world. They also have a system integration business. They acquired a company called Dimension Data, so they also, provide hardware and manage the hardware for clients as well. So there's a whole managed services and hardware business as well.
Okay, okay, okay. Got it. Okay, uh, okay. And so what was your itch that you could not scratch within Entity that made you want to step out and
So I'll tell you, Entity was very nice to me. Not only in terms of the acquisition, we got a fair price, but we also, I think it was a win-win because even Entity benefited a lot. So it was a very good relationship. I've still continued on the board because of the great relationship with Entity. And by the way, Entity is also invested in my new venture. So, so my last role in Entity, as I said, was so what one of the things that Entity did was that the data center they try and kind of separated the asset heavy business from the asset light business. So the managed services, the integration, the software development became one piece, although everything came under a global head. But the asset heavy, which is the data center co-location business, the submarine cable business, so they made me in charge of the data center and submarine cable business of the for the entire world, right? So I used to report to Abhijit Dubey, who's overall entity global head. So he was running entity outside Japan. He was run by Abhijit, and I was running the data center division, um, um, and the submarine cable division under Abhijit. But the managed services, the so till about 2021, I was running everything, including the data center, including the managed service and all. But then later, and from 22 23, I ran only the asset heavy business. Now, around late 22, early 23 is when ChatGPT became popular and AI just took the world by storm, right? And we were getting requests on our Simply Cloud offering for customers for AI workloads. And they were saying, can you provide a GPU infrastructure as well, right? And um, at that time, I tried to socialize this within entity that, and there were emergence of providers like CoreWeave that came out in 23, and I tried to socialize this within entity saying that should we look at doing this. They felt they weren't sure, right? Even today, the world is divided as to whether that's a good business model or not, right? And only time will tell how good a model is. But maybe because of the conservative nature, they decided not to do that, and that's one of the reasons I said, okay, maybe I can come out of entity and start something on. Also, what happened is my because my role was only colo and submarine cable, a lot of this IT stuff and all the happenings in AI, I was not able to participate in, and I didn't want to leave that part of because that's something that was close to my heart, and therefore I said, okay, maybe I can come out and start this on my own. Fortunately, when I decided to start something on based on the success of NetMagic entity, I had investors willing to back me without anything on the ground. And so Matrix India, which is now Z47, Nexus, which was my first investor in early investor in NetMagic, and Entity VC, which is the venture capital of Entity, backed us, and we did two rounds, one in March 24, seed round of 20 million. That time we were focusing more on the software piece, the orchestration, the platforms, etc. And we bought some GPUs with that money, and when we saw good traction, we raised another round from the same investors in October, and raised another 30 million from them, and set up larger GPU infrastructure. We actually our servers, our GPU servers, are actually housed in the NTT data center itself.
Okay, okay. Uh, is the biggest customer for data centers would typically be cloud companies, right? They would have the maximum
Yeah,
demand for data
yeah.
centers,
The
right?
hyperscalers are the anchor customers. Biggest
Uh,
customers are hyperscalers, but
so even for NetMagic in India, the biggest customers were these cloud
hyperscalers, yeah.
hyperscalers.
And so
Okay.
hyperscalers came to India in 2015. That's when data centers became mainstream in India. Where till 2015, there were largely five companies that were driving data center business in India. We were focusing more on enterprise customers. So we had banks, we had financial institutions, insurance companies, broking houses, manufacturing companies, pharma companies as our clients, media companies as some of our clients, a lot of startups were our clients. But when the hyperscalers came, the floodgates opened. So from 2015 on, when Amazon, Google, Microsoft, between 2015 and 17, they all entered India, and then the data center became one of the hottest areas, industries in India, growing very fast, and one of the probably one of the fastest growing markets in the top five markets in the world, right? In terms of growth. Yeah.
Mm. Do these hyperscalers also set up their captive data centers, or they
Yes,
typically
they
work
do.
with?
Yes, they do.
Okay,
So they do both. They do
okay,
their own captive. They have the teams that can build their. They are totally capable of building their own, but they also use third-party data centers because the rate at which their services are growing, they can't fully do it captive because the speed is important. So sometimes, let's say they're building a new facility and suddenly they need a large amount of compute infrastructure to be deployed for their clients. So they need space for that, and so then they would contract with a third party provider like NTT.
I think the internet traffic is growing exponentially, right? I remember,
Absolutely.
like
Data and
in.
traffic both are growing
Mm, mm.
exponentially.
Okay, okay. Interesting. So, what is the difference between a regular cloud hyperscaler and an AI cloud?
No, okay. The hyperscalers offer both. In their cloud offering, they offer, for example, Amazon. In addition to the platform that I described earlier, they also offer something called SageMaker and Bedrock, where you can build your models, train them, and inference them. You can also get an inference endpoint, so you can get, like, for example, a Llama model or any open source model like Llama, DeepSeek, etc., available as a service that you can then directly use, right? And Amazon, Google, and Microsoft offer both traditional compute as well as AI compute, and they offer AI training, fine tuning, inferencing, everything. Right? They are entire platforms to enable all of these. What we're doing in Neysa is only focusing on the AI workloads. So we're not trying to do everything. We're trying to focus on the AI workloads, and we have a flexible model where we offer private clusters for high performance computing, but we also offer public offerings so that people can collaborate and startups can use it, etc.
So, like NetMagic didn't have the AI
Yeah,
offering.
we had the cloud offering, but we didn't have the GPU compute. So
Okay,
now what we've
so
done is one interesting thing that we've done in India is our GPU compute now, we've connected it through APIs to the old NetMagic Simply Cloud. So now Simply Cloud can leverage our GPUs. So if Simply Cloud now wants to white label us and offer that as a service to their clients, they can leverage our GPUs. We are in the same data center, and so we've done a cross connect between the two clouds. And so if a Simply Cloud customer wants GPUs, they can just on their portal show orchestrate our GPUs as well.
got it. Okay, okay. Uh, The difference between regular cloud and AI cloud is essentially just the GPU versus CPU.
Yeah.
Regular
So
cloud has
in
CPU,
an
AI
AI
cloud
cloud,
has GPU.
you'll have, so on the infrastructure side, it is the GPU infrastructure. Also, the networking for that is different. You may use either InfiniBand, or even if you use Ethernet, you can use a slightly different way of doing networking. The other difference is, so that's on the infrastructure side. Also, the storage that we use is slightly different in the case of typically we use the storage like Vast and Veka as popular vendors that we use in our storage infrastructure. But But keep the infrastructure aside. You're right. I mean, I could use the same storages even for my traditional cloud. The main difference is the GPU from an infrastructure side perspective. But then the platforms are different as well, because the orchestration platform is different. You have these entire machine learning operations, or MLOps pipeline can be offered as a service, where a person can ingest data, then select a model, train a model, fine tune the model, and then do inferencing. So that entire process is automated, right? And then you have another platform, which is a low code, no code platform, where I can offer where a business user without writing any code can leverage an LLM of his choice and actually build a Gen AI app, right? So the platforms will be different, and from an infrastructure perspective, you're right. The main difference is providing the GPU compute.
Okay. Um, let's take the example of ChatGPT. Uh, how does ChatGPT manage their hardware? Do they have their own GPUs, or do they work with, like, say, an Azure? I'm assuming Microsoft is the investor,
Yeah,
so
yeah. So
Azure
they
provides
work.
them.
They have a combination. They work with Azure, and they work with, now they also have GPUs with CoreWeave, where they rent these large number of GPUs from CoreWeave, which is a neo cloud provider like us in the US. Of course, they're the largest in our space, and so they use a combination of Azure and CoreWeave to offer to run their ChatGPT application on top of. They do, obviously they have their own machine learning engineers. They have their own people who do the fine tuning, the training, and these are tens of thousands of GPUs, or if not hundreds of thousands of GPUs that they've deployed over a period of time, that they use to train their various models, and then they do the inferencing also on Azure slash CoreWeave. I think in some cases Microsoft has taken space from CoreWeave and put the OpenAI infrastructure on top of that, and in some cases CoreWeave, I think OpenAI is directly contracted with CoreWeave, if I'm not mistaken.
Okay. Um, what is the life cycle of building an AI model? Like you said, you use a bunch of terms like machine learning operations, training, fine tuning, inference. Just
So
help me
typically,
understand
when
these
you build
terms.
a machine learning model, right? First of all, you need data. You
Hmm.
need to ingest data. You need to then clean and normalize the data. So you do what is, and then you need to do feature selection. So there are different features. What features are going to make the model relevant? Then you do model selection. Which model to use? There are some well-defined models that you can use, and or you can build a model from scratch, and then you do a training run, and then you do you may have to have multiple training runs, because depending on the accuracy that you get, you may have to do multiple, and then finally you get an inference endpoint, which you then run as a service. So you take that endpoint. Again, inference endpoints can be offered two ways. I can do a dedicated inference endpoint, or I can do a shared inference endpoint, where I offer, for example, DeepSeek as a service, and anybody can use it, right? Or I could do a DeepSeek for an HDFC bank, or a Llama model just for an HDFC bank, so that their people can fine tune it, their people can put their own data, and then run their own app. And it's not so that the advantage of that is twofold. One is it satisfies the regulatory requirements, because it's captive, the data is not going somewhere else, and secondly, because it's open source, it becomes very cost effective as well. You're not paying the huge cost per token that you would pay, for example, to an OpenAI, etc. But obviously, since OpenAI is a larger model, the accuracy of OpenAI may be higher. So some cases people use OpenAI, some cases people prefer open source. My gut feel is that over a period of time, 60 to 70% of the training is going to be on open source models, because open source models are also becoming very, very good. So whether it's DeepSeek, whether it's Llama, or whether it's Quen, they're all doing really well. Yeah.
Okay. What is an inference endpoint?
So what happens is, when once you train a model, you get an executable, right? And that is something that I can deploy on some GPU cluster, and then make it available so people can access that using an API. So, for example, in ChatGPT itself, the application runs in a cluster somewhere, and my app actually connects to that cluster, sends a prompt, and gets a response. So the output of the training is a executable that I can run as an inference endpoint. End of the day, it's a prediction. Inference means prediction. So you give a prompt, you get a response back, right? So I run that on some infrastructure, and that's what I mean by an inference endpoint.
So, what is the cost differential for a business to, so if I'm a, like, say, an HDFC, okay, now let me not take the example of banks because there is a data localization
Yeah,
regulatory requirement, but let's say if I'm running a Zomato, and for customer service we are replacing uh, customer service agents with a chatbot. So what is the cost implication for just using an OpenAI API to build my chatbot versus an open source, like training something on
model and
Llama
yeah,
and then using?
great question. So what again? This will change over a period of time because cost per token is coming down, etc. But what we've noticed is when you scale. So if I have just a few queries, then it doesn't matter why I have the headache of setting a renting infrastructure, deploying a Llama endpoint, and then querying it, building your app, etc. I just straight away send an API call to OpenAI and just do it, do your job. So as you scale, right, the cost per token, and token could be a full word or it could be a partial word, depending on different people define token differently. The cost per token adds up to a lot. When you have billions of tokens, right, your cost per token, and I don't know what the current pricing is because it keeps coming down. Anything I tell you, it may have already changed last night. But the cost per token becomes pretty significant if you use a paid model like OpenAI, and then also Gemini is cheaper than OpenAI, but even that's pretty significant. If I'm using open source model, then I'm just paying for the infrastructure. The cost per token will be typically lower because the OpenAI charge or the Gemini charge is not there, right? So it's just the infrastructure cost. When the number of requests or number of tokens is not huge, then it just doesn't make sense for people to necessarily build everything. But if they believe that over a period of time they're going to use billions of tokens, then it's probably better to use an open source model with um, some dedicated infrastructure.
So, if in this example, like says Zomato for their customer service was felt that they will need to use billions of tokens, so what would they do? How
So one
does a
option,
company go about?
what we would urge them to do is we would provide them some infrastructure with an open source model. If they found that they may have to change their prompts a little bit because they could, there is a way you can this exact same prompt that works really well on OpenAI may not exactly work as well as Llama, for example. So there are actually these prompt translators that Meta provides, for example, and if they got reasonable output from the open source model, then they could just rent the open source endpoints from us either as a dedicated or as a shared endpoint, and they would find that the cost per token would be significantly lower than what they would get from an OpenAI or um, even a Gemini.
uh, for the development team at Zomato, it's the same effort. Like, it's just like with OpenAI, there's just an API call.
Yeah,
Similarly, there will be just an API
yeah,
call
yeah,
with Neysa.
yeah. They could do API calls or they could just do prompts. Right, depends on
Okay.
uh, what kind of
Do they
application.
need to know how to train a model and have that? Like,
No,
is there that
but
additional
I
one-time
think
investment? Like,
no, they don't have to train a model, but using OpenAI, you can fine tune models. So they don't have to do any foundational model training, but they can do fine tuning. So they could do where they may change. The fine tuning could be, they could add their own or they could use something like RAG where they add their own data contextual to bring the right context. Rather than training on the entire universe, you train on your contextual data. So a combination of techniques like RAG and fine tuning is something that they could use to and they could do that with OpenAI or with an open source model.
what is a SLM? A small language model would
So,
be
where the
similar
number
to.
of parameters is much
Hmm,
smaller.
hmm,
Today, OpenAI's latest models are being trained on trillions of parameters, right? Or 671 billion, 700 billion parameters, etc. Whereas you could have a small model, a language model that's trained on 3 billion parameters, 1 billion parameters, and they may be good for a particular task. They may not necessarily have to go through everything, the entire universe of data, and have multiple parameters. It could be, they could do a small task really well, right? And so you have, but the size of the number of parameters that the model uses is what determines whether it's an SLM or an LLM.
okay, 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 got it. Okay, understood. So, like at Nesa, what all do you abstract away for your customers? Like a lot of what cloud businesses do is abstract away complexity, make things
Yeah.
easy. So
Yeah,
I'm
the
sure in
entire
AI cloud.
complexity of network, the
Hmm,
storage, the
hmm,
GPU infrastructure, configuring it, getting it up, etc., is completely abstracted. It can be all you can provision a virtual machine or a container or even a bare metal GPU by it's completely the entire provisioning of that is automated. You can scale it up, you can scale it down, right? You can add more storage, reduce the number of storage, the amount of storage, etc. All that can be completely orchestrated. Then from a platform perspective, we can give you a shared workspace. So if you want to do a collaborative project with multiple AI researchers, that can be done very easily. We can give you a Jupyter notebook so that you can write your Python code again in a collaborative workspace environment. We can automatically, once you finish training, you can just press a button, it creates the endpoint, and you can with a simple user interface, you can publish that inference endpoint so that it can start doing the inferencing. So the entire journey is automated. And we have two developer platforms, one for the entire machine learning operations process, right from data ingestion to feature selection to model selection to training to fine tuning, as well as the low code no code platform that allows you to build Gen AI apps by selecting the right LLM. We have a series of LLMs that you can choose, some hosted by us, which are open source, and some through an API called like OpenAI that you can use to build Gen AI apps. So the entire underlying infrastructure complexity is abstracted away.
okay, so one product is this, which you can use to build a Gen AI app. What's the second product?
The machine learning, if you want to build a machine learning model of your own, like for example, we have customers building a machine learning model for fraud detection. Now they may or may not use an LLM for that. They may use their own model for doing that, right? There's a client that is using one of our models for drug discovery. Again, they're not necessarily using a standard LLM. They may use something like a BERT, and they may do some fine tuning by changing the last layer of BERT, etc., to do that. So these are examples of people using our platform. Not only and then we have people using bare metal. Some research and education institutions are just using bare metal infrastructure, which again we provision in an automated fashion. Very easy for us to provision a whole bunch of GPUs and create a cluster and give it to a client, so that they can then use it to run some high performance computing workload. It could be a training of a foundational model.
Hmm. Got it. Okay. So, the NetMagic business was like an asset heavy business. So you would probably be spending a lot of time in procurement, like be it real estate, be it hardware, etc. What is the NESA business like? Is this also
Neysa
asset
is
heavy? Or?
also so the Neysa, the software piece, the platform that we are building, etc., is obviously not as capital intensive, but the GPU infrastructure that we build, that is capital intensive. GPUs are
Okay.
not.
So you're working with third party data centers, or you have your own data center?
No, we are working with NTT, so third-party
Okay.
data center like NTT. But we could use any data center that we want. We don't have to use NTT, but obviously, given the relationship and given the uh,
Yes.
comfort, because I also know the entire team that's doing this. It's the team
Hmm.
that I built.
Right.
Obviously, and we believe they're the best in India, so we've used NTT as our data center partner.
Okay. So you're using their co-location service.
Yes,
Okay.
yes.
Okay. Okay. Got it, got it. So here the procurement that you have to do is not the real estate part of it because you're using a
No,
co-location
we're not doing
service.
any real estate procurement. We're not doing
Hmm.
any mechanical and electrical. We're not building any build a facility with air conditioning, etc. That we're taking. We're just renting that from NTT. We're
Hmm.
procuring the servers, GPU servers, the storage, the network, the load balancers, the firewalls,
Hmm.
setting it up together, and then putting our software layers on top, and then offering it as a service.
Okay. It seems to me like the data center business is a supply first business. Like it's a business where the founder needs to solve for supply rather than solving for demand. Do you agree with that? That you build supply, the demand is there.
Yeah, true. It is the demand as of this stage in certain areas, like especially in cities like Bombay, is more than the supply that is there, because it takes 15 to 18 months to build a large facility, and so it's even though there are now multiple players, um, there is the demand outweighs the supply. May not be across India. Maybe in some markets there's not so much demand, but in markets like Mumbai, Bangalore, Chennai, the demand is more than the supply. Yeah, that's absolutely true.
So what skills does a founder develop in that kind of a business, which is supply constraint rather than demand constraint?
Um, well, it's efficiency in executing, building the right team. The finance is important because you need to raise a lot of capital, so do it most efficiently. Then execution, we need to execute on timely execution is important. So the project management skills, etc., become very important. So it's a combination of HR, finance, execution, operations is important. You have to, it's a very, very mission critical business. A single second of downtime can bring down the entire business. You can't have a data center go down. So the attention to detail, the operational, focusing on making sure that the operational processes are streamlined and are top notch has become very important. So yeah, all of these are very very important in a in a even though it's a supply constrained business, it's a very important business. And how do you identifying you have to constantly be looking out for the latest because technology changes. You want to make it as sustainable, as energy efficient as possible. Designs change, so you need to also do some R&D, if you will, where you're constantly testing new technologies so that you can then at the same time to make it sustainable. We in the data center business we had a lot of we built a lot of captive solar and hybrid wind solar plants. So that's something that we also did in with partners, but because that was not our core competence, but we did it with partners. So just knowing, I mean, there's a fair amount of work in all of the above, right? There's the entire M&E piece. There's then of course there's the network. How do you scale the network? How do you interconnect your data centers in the most efficient manner so that you can offer services across data centers as well? There may be some services I'm offering from one data center, but I can seamlessly make it available across multiple data centers. So many such things that we have to do. Um, yes, but I agree with you. Currently, the data center business is supply constrained. I mean, the demand is more than the supply. I wouldn't say it's supply constrained. There is supply also, but I think the demand outstrips the supply in certain pockets.
Okay, interesting. Uh, is it same for the cloud AI data center business?
So I think cloud, I believe it will become there. I think it will very soon become that. I think if I look at it and I compare what my journey with Neysa with my journey with NetMagic, it's very similar. Initially when we set up data centers, it took a while before there was widespread adoption. At that time, we had to deal with different things. People were scared of outsourcing to a data center. They wanted everything inside their premises, and so we had to, completely shift the mindset. And that happened over a period of time. So banks, were building their own captive data centers. They were not comfortable outsourcing their core banking infrastructure outside. But that shift, I saw that shift happening over the years that I did. And then once that happened, and once hyperscalers came, it became huge, and it became a supply constraint or demand outstripping the supply business. In the AI space, also, I believe this will happen. I think it's early days. I think there's awareness. People in enterprises are still doing proof of concept. 70% of all enterprise workloads are POCs. They've not yet started. There is some amount of widespread adoption when it comes to things like fraud detection, things like customer service, etc. But there is still a long way to go. And I think once the awareness, once the models become better, there's more awareness. I think this business will also become. If you look at the U.S., right, service provider like Corby, demand is outstripping the supply, right, and so I suspect that something similar will happen in the next 18 to 24 months in India. But right now, I would not say it's supply constraint right now.
Okay. Okay.
I think
So
it's early
you
days.
said like fraud detection, customer service. These are like low hanging fruits where enterprises are
Yeah.
adopting AI. What are the next not so low hanging fruits where you think there can be massive
No, so
AI
there are
workload?
two broad categories. I won't go into specific. I'll talk about two broad categories. One is to automate their internal operations, right? So you want to use chatbots instead of hiring agents. You want to do document summarization. These are things that people have already started doing, right? But when they want to do something which is where they want to change the way they're doing business, or they want to fundamentally do innovation which gives them an edge over the competitors, that is something that I'm not seeing happen as much. I think people are piloting that, but they're not doing it as much. Even the voice bots, right, to call. Let's say there's a client that did a pilot with us which where they were calling were doing loan collection using a voice bot, but they didn't take it to production yet, even though it saved them significant 67% of the cost. From 15 rupees a minute, they came down to 5 rupees a minute. But they haven't yet taken to production because they need to make sure the accuracy is high. In some cases, maybe a regulatory thing that they need to overcome. But it's only a matter of time. I think it will start happening. You've already started seeing it happening in the West, so it'll start happening in India as well. So we are seeing a lot of training happening with the research and education institutes. We are seeing startups use it a lot. We are seeing the early adopters in insurance and banking already use it. But widespread adoption. I think also what happens is you need to have a proper team within the financial institution or the enterprise that understands what they can do with AI. So I think a lot of people are going through that journey. They're doing pilots, but I think the pilot to production will probably happen in the next 18 to 24 months. And once that happens, then I won't be surprised if the demand outstrips the supply.
Okay, okay, okay. Interesting. Um, so this AI cloud business is also then, I mean, capital is a moat here, right? Like the more capital you're able to raise, the more you will have capacity, and more capacity means lower overheads, or your overheads get distributed, so your costs, yeah, like you're able to offer at a better
Yeah,
pricing.
but you have to be careful, right? Because GPUs become obsolete first. So yes, capital becomes important because if you have access to capital, you can build larger infrastructure. You have larger infrastructure, you can get larger clients coming to you. But at the same time, it shouldn't be the case that you build so much inventory that you don't have enough usage, and then like in a data center, even if I went a couple of years without usage, it didn't matter because that infrastructure didn't depreciate. It was more mechanical and electrical. Here it is high-end GPUs. In 2 years, Nvidia would have probably launched fourth generation of GPUs, right? So you have to be a little careful here in terms of you need to make sure utilization is there. So pure speculative build out of GPU infrastructure, you can't do blindly. You need to have some anchor again here. So I think the common thing in both businesses is it's very capital intensive and both require anchor clients. But I would be a little bit more cautious on the way I deploy GPUs than I would have built data centers, because in the case of data centers, look, real estate in India only appreciates, it doesn't depreciate, and the mechanical electrical equipment actually has a huge lifetime, right? So it doesn't, yeah, it's not something like so. But when you're building server infrastructure, that has a I would typically data centers can depreciate mechanical electrical equipment in 15 years, but the server infrastructure is depreciated typically within 5 years, right? So you would have to be a little careful. So you don't want to be too ahead of the curve and build out so much that by the time the demand comes, the GPUs are obsolete. But I think that's where the past experience has, because we built a compute cloud as well, which had similar characteristics. So we that past experience comes in handy in making sure that we know when to order new equipment. Of course, the one more difference is that it takes longer the lead times for GPUs is longer than it was for traditional compute, for CPU compute. CPU compute would come in 2 to 4 weeks. GPU compute, depending on the model that you order, can take anywhere from 6 weeks to maybe a few months. So your planning has to be accordingly.
Hmm. Uh, What does the economics of a cloud AI business look like? How much of your spent is on GPU?
A very significant percentage of our spend, typically in a almost, I would say, close to 80% of our spend is on GPU and associated infrastructure. And about so in our pricing, when you're doing the pricing for a client, roughly 80% of the cost, 70 to 80% of the cost is GPU and associated infrastructure, and about 17% is colo power and colo and power and maybe network, right?
Wow. Okay. Uh, so the data center business is measured by gigawatts, I believe, megawatts, gigawatt, like how much electricity is being consumed. Is it the same way to measure cloud AI capacities?
You can do it in number of GPUs, or you could even do it in terms of
Okay.
kilowatts or megawatts you consume.
Mm.
But you could do it in typically the parameter seen using, like people say, CoreWeave has deployed 250,000 GPUs.
Okay.
That may translate to 250 megawatts, but people,
Mm.
so
It's more GPU is
so
the way
more
to
based on
measure.
GPUs than
Okay.
on
Okay.
power that they
So
consume.
there are some like Nvidia's latest chips are not easy to access, right? Like the top end. I believe China cannot. There are
Yeah,
export
China cannot
restrictions.
access even their earlier Hopper, the entire series of Hopper. So what happened is, there are some countries where the US has banned the sale of these chips. So, for example, China, Russia, Syria. There's some countries that are blacklisted. Earlier, they would allow lower generation chips of NVIDIA to go there. That, I think, I'm not sure what the current status is, because when the Biden administration, before they left, 1 week before they left, they came out with a diffusion policy rule where they divided the world into three buckets. Yeah, some 18 to 20 countries were in tier one, where there was no restriction on GPU sale there.
Is
The
India tier one?
No, then there was tier two, which was there. Tier three, which was the Russia, China, and all these, where there was nothing allowed. And then there was 150 countries, roughly, including India, were in tier two, where there was a GPU cap. This was supposed to come into law on 15th May, but Trump removed it and said he will replace it with something. So, to my knowledge, right now there's no restriction on India, but we don't know what. Maybe Trump will use it in this trade negotiations with us, and with other countries. This could be one of the bargaining levers that he has. But yeah, so we don't know what the restriction, if at all, will come in the future. But even other than that, if there's so much demand for Blackwell chips that Nvidia has, that if I were to order something today, it will take at least 4 months before I get allocated some Blackwell chips. Whereas the Hopper series, I can get between 4 to 6 weeks. So an H200 I can get within 6 weeks, but the Blackwell chips taking time. Right now there's even a huge lead time in the networking gear. So whether I order the InfiniBand Mellanox switches, or whether I order Ethernet switches that are the right switches for AI, there's sometimes there could be a 4 to 6 month lead time there also. So you have to plan this really well, because the demand is so huge in the US.
Okay. Chips come from China. These switches, sorry, chips come from Taiwan. The switches come from China, or like
No,
where do
no,
they come from?
switches are, see, where Mellanox or Cisco or these guys make the chips. I think there are multiple places across the world that they make them. I don't think there doesn't need to be any dependence on China per se. You don't have to depend on China. There's Taiwan, there's Malaysia, there are different parts where these things are manufactured. Yeah.
Mm. Does AMD offer chips comparable to Nvidia?
Yeah, yeah. So AMD is offered the MI 300. We bought some MI 300X also, and we bought they now. I think the current model is the latest model is MI 350. The on the raw silicon performance, they are second to none. The underlying hardware performance, but the challenge is where Nvidia's moat is and why they own almost 90 to 95% of the market is because of the CUDA libraries and the CUDA software, right? So that to do parallel processing, they have this entire libraries that people use, and Nvidia's equivalent, AMD's equivalent is called ROCm, right? Now Rockham is so if I use something like PyTorch to do my development, then the model typically would work on both AMD and NVIDIA because NVIDIA has something that translates to Rockham. But if I use native CUDA in my application, CUDA library in my application, then I would have to rewrite the code on AMD. And that is where NVIDIA scores huge. And that is why people don't want to bother with all that and they just go ahead with using NVIDIA. And so that's why NVIDIA has got roughly 90-95%. I don't know what the exact market share, but over 90% market share is what NVIDIA has. But there are AMD is making big progress, so I think expect AMD to make some strides in the coming years. There are also some companies that have got specific chips for, let's say, just for doing large language models. So that they've been rather than a general purpose machine learning chip which can do any task, they focus their attention on specific tasks, right? So even the chips are designed that way. So interesting companies to track are um, Samba Nova, Grok, Cerebrus. So we are in discussion with multiple of these companies to see their future roadmaps to see how we could deploy some of these. Some of these are good for inferencing. For example, Samba Nova is specialized in inferencing, right? So we're looking at that as well. Yeah. But right now, bulk of deployment, I mean, almost all our GPUs are NVIDIA GPUs, and across the world, I think that's the case.
Hmm. So there's this massive FOMO, that fear of missing out in India, that India will miss the AI wave. We will not be able to create a large language model. What do you think is the India opportunity in the AI space? Where do you think we can actually compete? We probably cannot create a large language model because of the billions of dollars of investment needed, but what can we compete effectively in?
No, so for example, there are several companies, and even the India AI mission is funding companies who want to build LLMs for Indian languages, right? So that is something that India is doing, and that's very important. Although I must say that even OpenAI and others do a great job on Indian languages, but there are so many different languages, there are so many different dialects, there's so many different contextual meaning that may not
But
get
that's
captured.
not like a global opportunity, right? Like
No,
building
I'm
LLMs
saying
for.
for sovereign AI, that
Hmm,
is an important opportunity because
hmm. But
bulk of
if you want to catch this bus, the AI bus, what can
no. So
India
there are so many.
realistically
No, so
do?
so today, for example, typically India was doing back office work, right? We were
Hmm.
doing outsourcing. People would we would write software for people here, etc. Now, for two reasons, now we can because we have access to AI tools locally, we can actually build for the world. We don't actually have to just outsource stuff for the world, right? And
Build as in using products, like
products,
India
right? We can
could do
create
more
products,
product
AI
software
enabled
products.
products. We can build from here. Another
Like
reason
AI
why
native
we have
products.
to do this, we have to think the product mindset is
Hmm.
because the labor arbitrage opportunities. That the negative thing for AI in India is that we used to count all these large software companies like Infosys, TCS, etc. used to mainly rely on labor arbitrage, right? That labor arbitrage now, if you have access to LLMs and you have access to tools like Cursor and others, you can that labor arbitrage is pretty much gone, right? Will go in the next. Maybe there's still some labor arbitrage, but it'll go in the next step. Now we don't need a team of 100 people developing. We need a team of 2 or 3 people developing using these tools, right? Because you can do much faster development. So that is a risk that we face because then you suddenly don't need that much outsourcing done. But at the same time, it also is an opportunity because now we have access to the same tools and we can actually build for the world. So I think we need to move our mindset from an outsourcing mindset to a product development mindset. That's where the opportunity is.
So let me end with this. What's your advice to the current generation of founders?
So first of all, it's dream big, right? Especially with AI, you've got this opportunity to create something from for the world. You just don't have to look at India alone. But I'm going to give you the advice based on the lessons I've learned. And so one of them is empathy towards all the key stakeholders, whether it's your employees. So one of the things I'm proud of is I've never laid off an employee in my 25, 30 years of entrepreneurship. There have been tough times. We went through the dot-com burst. We went through the 2008 financial crisis. But I don't believe in laying off people just because there's a blip in the business. Um, and you need to be empathic towards your investors, completely transparent, so that things are going well. Sometimes you obviously you'll share that news, but lot of time entrepreneurs try to hide stuff from investors if things are not going well. Obviously, you have to be transparent. You have to be empathic towards customers. I still remember we had an example of a very large financial institution today, which was struggling to stay alive in 2000, 2001 when the dot-com bust happened. Today, it's one of India's largest financial companies. And we were, the founder came to me and said, "Look, I can't pay you, but I'll pay you over a period of time." And we worked it out with them. He also couldn't retain some of his employees, so I took over some of his IT employees, and they became part of my team. It was a win-win for both, right? So that's the one. Then surround yourself with people that are smarter than you. You don't want yes men in the business. Never compromise your core values and ethics. In India, there are a lot of temptations, but just stick to your, think long term, right? Don't think short term. Um, you have to collaborate, especially with startups. You cannot do everything yourself. There's some incredible startups, right, that you can collaborate with. Second thing is agility is key. You can't take very long to make decisions. You have to take quick decisions. You may be wrong sometimes, but that's okay. Make quick decisions. Obviously, you have to have self belief, passion, and hunger. If you don't have self belief, you don't are not passionate about what you're doing. You can never. How will you ever convey that to your customers? Or how will you ever convey that to your stakeholders? This is a cliche, but there's no substitute for hard work. Nothing comes easy. Um, Constantly learn and upskill yourself and your team. Um, so it's very easy to find faults in others, but find the strengths in your team and and help them overcome their faults. Very often you say, "Oh, this guy is always doing this," or "He's always negative." But there are some good qualities in a person also. So try and amplify the good qualities. Uh, Take risks, but obviously fail. But even if you fail, it's okay. Fail fast, but don't repeat the same mistake again. And obviously, when you're taking the risk, you look at the upside and the downside. If the upside is huge and the downside is limited, it's a no-brainer, right? But you can't take a risk where upside may not be that huge, but the downside could sink your company, right? Obviously. Then I believe in progress over perfection. I won't wait for something to be perfect before I launch it. I will take version one, launch it, get feedback, improve it, etc. I believe you should find a mentor, right? Like in my case, it's Mr. BV Jagdish, who's been a great mentor to me. Even my some of my board members are very good mentors. Um, don't be afraid to embrace the unknown, right? So sometimes you're in a situation, you don't know if something will work or not, but you know, you know be fearless, and as I said, dream big. So those are my advice to entrepreneurs.
How old are you now, Sharad?
58.
Wow. How do you
I
still
started,
find
Neysa
the energy?
I started Neysa at the age of 56. Yeah.
Wow, that's amazing. That is amazing. How do you still find the energy, the drive to, to take on such a
AI
large.
is such an exciting field. It's so much to learn, right? I'm like a dinosaur in this field, right? The team that I have is so amazing. The amount of knowledge that they had, is and there's so much to learn, right? That's what keeps me going.
Hmm, amazing.
Just
Thank
interacting with my team is learning from clients, learning from partners, learning from my team is constant learning.
you.
And if there was no if there was no learning, I would probably not have the energy to do this. But there's so much
Mm.
learning every day. You learn, right? So
Thank you so much for your time, Sharad. I truly hope that by the time I'm 58, I'm like you. Thank you so much.
Thank you, Akshay, for your patience and for the lovely discussion.